Well, hello there again, friends. Today is 8/11/2022, and today is the Odin Project Vlog Day 140. And today I have breached the a little bit of computer science section, and I have completed two modules for today's video: a very brief intro to CS, which is abbreviated for computer science, and recursive methods. Um, so, just a little admin tip to get out of the way here before we get started, or to let you know. Saturday, my family and I've decided we're going to take the day and we're going to go to our state fair in our state. So, we'll be gone all day, so I won't have any time to work on anything. And so I'll get what I can done on Sunday. I see there's a project coming up, so I may get a video out over the weekend. I may not, depending on. I haven't looked at the project, depending on how I go about it, how much I get done, I may or may not put up a video. Just wanted to let you know. So with that out of the way, let's get started. So this is a very brief intro to CS, and it's kind of funny they stuck this in, and I feel like I'm kind of warped back and went back in time, so to speak, because this is pretty basic stuff here, at least on this page, or this module. So we're just gonna do the knowledge checks real quick and move on. It's not a very big module. There are quite a few things. They're mostly watching things. In fact, 3 of the 4 assignments are watching videos. Excuse me. Tourette's is active, as usual. Watching these are great watchers to learn about a little more about algorithms and pseudocode and stuff like that. So that'll be for you on your own. So the first algorithm goes out, or first question is, what is an algorithm? It goes out to YouTube page, which no point in clicking on that, but I'll just answer the question. So an algorithm is a step-by-step set of instructions to complete a task. In our case, it's to solve for an answer using code. That's essentially the nuts and bolts of what an algorithm is. It's really a step-by-step set of instructions to do anything. And like I said, in our case, it's using it to write code. Second question is, what is the importance of algorithms in web development? So this does go out to a article that you read in the module, out to Quora here, and it's lengthy. It's good, but I'll let you read it on your own. Excuse me. Where is the importance of algorithms? I didn't open up this one. Hang on. I read this one. So, what part do algorithms play in modern web development, specifically user-based websites? So, basically, the question asks what's important. What is the importance of algorithms in web development? So basically, in a nutshell, they become important because you have a lot of data that you have to process, or when you're performing complicated transformations on that data. So the algorithms become important when you have lots of data to work with. For example, consider the Quora search engine. You probably could develop a similar search engine without much algorithm experience. However, once you gained thousands or millions of users, your site engine would become unstable and not able to handle a large bandwidth of requests. There'd be simply too many users requesting to search too many documents, and at that time, that's when an algorithm would help you. Algorithms let you figure out efficient ways to handle large amounts of data. So he goes into a CAPTCHA example on that. So I won't go into that. Let you guys read that on your own. And then last one's another YouTube to redirect for what is pseudocode. So basically, pseudocode is an English-like way to state an algorithm, usually written out on paper in order to help a software engineer break down a coding problem, as per in our case, as in this example. And we're not new to pseudocode, at least I'm not. Most of the things I work on, I either do start out with pseudocode, or I end up there if I get stuck early on, like in my planning stages. I'll write it out first. It does help not only to keep organized, but to break things down into smaller workable chunks. So that's always advised when you're troubleshooting or having a hard time just getting going with something, is to break it down into smaller pieces. And that's it. So the next lesson is recursive methods. This is really good. Take your time here. There's a lot to go over. I thought I knew recursion pretty well. Actually, I didn't at all. I knew recursion was different than iteration, but I really didn't know how different. And it's actually pretty different. So you learn about that here, and you read, and there's a few watchers here as well, YouTube videos, and then there's a test yourself, this code quiz. We'll come back to this in a second. Excuse me, because I want to go over an example of recursion with you in regards to one of the knowledge checks. But I highly encourage you to do this on your own. I did go ahead and take a crack at this on my own as well. I did pretty good. There were 9 of them. They got progressively harder as they go on. I think I won't show you the code, but I already closed it out. But it wasn't really, I didn't really plan that for this video. This video should stay short. So, but because the code quizzes answers are actually on there. They're just hidden if you get stuck. But I think I got like 5 of the 9 probably right without struggle, and then I tried on the other 4 and I wasn't able to get it. So I just reviewed their answers. So and they're just saying they're not expected to answer them. You're not expected to answer them from memory at this point. So we'll come back to that. So let's hit the knowledge check. The first one says, how would you briefly define a recursive function? And that just goes right back up here into the intro. And recursion is the idea that a function calls itself. Pretty simple, right? It's used to take a big problem and start breaking it down to smaller and smaller pieces. The idea divide and conquer, and continue to feed their solutions back into the original function until some sort of answer is achieved and the whole chain unwinds. There's a lot more goes into it than that, but that is a 10,000-foot answer. And that does answer the question briefly. What is the point of recursion? Is it more efficient than using a plain loop? So I don't know if I actually read this page because I thought it timed out on me. So nope, it didn't. Did I skip this? Yes, I did. It timed out for me last time, so I ended up not reading it. So let's just see if we can answer it real quick. What is the point of recursion? Is it more efficient than using plain loop? Good old Control F. Okay. I'm pretty sure I understand recursion, but I don't know what it says about me as a programmer that I push this chapter to the back of the book. However, while it's fun and challenging to write recursive procedures, it's rare to find situations in which a loop can't do the same thing, sometimes faster. But it's important to at least recognize a pattern as you might run across a use case for it, and I agree with that statement. Even if a loop is possible, recursive solutions can be more elegant, and designing them are a good way to stretch out your programmer thinking muscles. Does that really answer it? What is the point? Not really. So, yeah, I didn't read that at all. I skipped it. I think it just didn't come up for me the first time, or it wasn't even. Excuse me, or it wasn't even in the docs. Actually, I think that's a bug. That's a bug. A bug in the reading, because actually there's no link at all to it. Okay, so it doesn't even have you read it at all. That's interesting. Usually every knowledge check goes over something that we've already read. So actually, no. You would not have read this if you just read the module. So yes, it's more efficient than using a loop at times. I feel like there's always a like if-then else catch type with these types of questions. So recursion's good if you need to go through something multiple times but you have to change the return statement. Like the thing that you return is different every time. Um, and and then you have a case where it's done and you need a base statement to get out of it. A loop, on the other hand, like a for loop, will iterate through the entire list no matter what until your for loop condition is met. So the difference there is that you will return the same item or multiple items over and over and over again. Um, and it is more elegant and efficient to write a recursion statement than a loop, but I think recursion has very limited use, I think, than a loop, or for loop, or whatever kind of loop you want to use. But for loops and plain loops are much more common. So I hope that kind of answers the question, because I didn't really find the answer to that. I don't want to make this video super long. That's not the point of today. Yeah. So if you want to read that on your own, you can. So I just found a little bug in the study here. Just gonna go ahead and move on. What are the two essential parts of a recursive function? So this takes you out to another YouTube video, and so I'll just answer it here. The two essential parts of a recursive function, I already kind of mentioned it. The the first one is base case, and then you have a second one called a recursive case. So your base case is when you're triggered, when your logic is triggered as true via an if statement, and that terminates the recursion, and it basically returns whatever you want to return, and it ends the recursion. The recursive case comes after that if statement, and that's the code where the recursion actually takes place, and it uses callbacks to call back into itself, basically. So you call itself to repeat itself in that loop fashion, that recursive fashion, until the base case becomes true, and then it stops the recursion. So to show you easier, just hearing me, to show you what it looks like, we're going to go out to this code quiz, and that's what I was mentioning earlier, that we come back to this. So if you come out here to the coding game site, we'll look at some all numbers. So spoiler alert, I am going to show you the answer for just this one here, so we can go over it. So you might want to pause the video right now if you haven't done this yet, if you're watching ahead and you're wanting to do this on your own. Otherwise, continue to follow along here. So we have right now we're going to sum all numbers is the question. It says write a function called sum range. It will take a number and return the sum of all the numbers from 1 up to the number passed in. So all I want to do is really just show you the difference. So here's your base case. This is what I was referring to. So if this is an if statement, obviously, so if this returns true, it breaks out of your function, and in this case, it returns a 1 to your output that becomes console logged out. So if that's not true, you always put your base. I think you always put your base case first, because it's going to not iterate. Sorry, I want to say always use saying iterate. It's going to recursively move over it. And through it over and over and over again. So you want to have your base case first. Otherwise, here's your recursive statement. It's just a simple return, but inside the return, you're going to have a number, and this is just doing the function of the algorithm of sum range. So you're going to have number plus sum range num minus 1. And I won't go through all of it because it's explained right here, but I just want to show you that this is the base case and this is the recursive case, and this is going to keep, as you can see, it's calling itself, and it's incrementing down. Num is incrementing down from 3 to 2 to 1, and then when it gets 1, it's going to return out because num is satisfied here in the if statement. So this if becomes true, so then it returns 1 and it breaks out. And so that's what I was saying about your base case, which when it's triggered will exit out of the recursion. So that's that. And then, why is Stack Overflow relevant to a recursive problem? So it takes you out to a Wikipedia article, and I'm not gonna lie to you guys, I read this slow and twice, and I still didn't understand half of what they're talking about in here. It's pretty complicated, at least to me. I don't know. Maybe it's because I haven't been exposed enough to recursion, but they're talking about stack size here, and it just says basically answer the question of why is Stack Overflow relevant. Recursive implementation of D and C stands for divide and conquer. Recursive implementations of divide and conquer algorithms, one must make sure that there is sufficient memory allocated for the recursion stack, otherwise execution may fail because of Stack Overflow. Divide and conquer algos are the time efficient often have relatively small recursion depth. And it says, for example, if the quicksort algorithm can be implemented so that it never requires more than log to n nested recursion calls to sort. So, yeah, it's meaty. Stack Overflow may be difficult to avoid when using recursive procedures, since many compilers assume that the recursion stack is a contiguous area of memory, and some allocate a fixed amount of space for it. Compilers may also save more information in the recursion stack than is strictly necessary, such as return address and changing parameters in the interval variables of the procedure. Thus, the risk of Stack Overflow can be reduced by minimizing parameters and internal variables of the recursive procedure, or by using explicit stack structure. See, it's a mouthful. Basically, Stack Overflow is more than just a site. It's relevant because it can make or break your divide and conquer algorithms. It can cause them to stop working if they're not allocated correctly, and this goes into a lot of memory space stuff, and you have to be kind of familiar with the way memory stacks work and memory allocation, how compilers save information. And so that's why I said, to me, it was kind of, I have a basic understanding of some of this stuff, not with how compilers work, but with memory stack and spacing and all that. But yeah, so kind of on your own on that one a little bit. I don't want to over-explain that, but yeah. So basically, you can have a program that can have a Stack Overflow, and so it's good to know why that would occur, when it would occur, and the limitations and what happens. So anyway, that is enough here. So with that said, next lesson is a recursion project, and like I said at the beginning of the video, if you stuck with me through the whole time, I appreciate you guys and love each and every one of you for coming along the journey today. I will be starting this next. I don't know when. I'm going to be out of town Saturday, going to our state fair with the family, so I won't be working on anything on Saturday, and then Sunday is kind of a cleanup day. I might get to do a little bit of work on it, so probably not going to get a video out, but who knows, maybe. We'll see. I haven't read through this yet to see how much is involved with it, but we'll see how that all works out over the weekend. Otherwise, we'll see you again next week. So with all that said, please like, share, and subscribe for more content, and let me know in the comments section what you guys think of these two modules, or if you moved on and you didn't go back like me and you're in React, let me know too. I'd like to hear from you in the comments. So with all that said, till next time, see ya.